Most candidates offered no response to this question. But don't take my word for it. Hear it from the examiners themselves. Today, I'll show you now that this whole question is actually much easier than you think. And the reason I make that claim is because, as you can see, the question is split into 3 parts, with parts A and B being much more simple than you would imagine. So that's 4 out of 7 marks completed. But then we also have part C, which requires a bit more thinking, I'll admit, but still, when you break it down, is much more simple. For part A, we're told to solve the equation and that P and Q are real constants. Now the confusion here is that we're obviously not given any values for P or Q. So you'd be forgiven for thinking, how the am I supposed to solve this? The question you need to ask yourself is this: what is the general solution to any quadratic equation? And as you know, the answer to that question is the quadratic formula. So what does a quadratic formula look like in this instance? Well, it looks like this, which can then be simplified down to this. And when we finally simplify it down, we get pi plus minus root q minus p squared. And that's the final answer to part A. Now part B is a problem that also seems confusing at face value. But once we dig into the nitty-gritty, so to speak, we uncover that the solution is actually much easier than we originally thought. To tee up the solution of this problem, we're basically given 3 clues. 1. The Argand diagram. 2. The roots are represented by both A and B. And 3. A and B lie on the imaginary axis. So, to summarize, A and B lie on the imaginary axis and are therefore completely imaginary. But what does completely imaginary mean? It means that both pi plus root q minus p squared and pi minus root q minus p squared are fully imaginary. Now obviously pi means that the p part is imaginary, but if the whole thing is imaginary, that must mean that root q minus p squared must be imaginary too. So when does this happen? This happens when q minus p squared is less than 0, because then we get a square root of a negative, which is obviously imaginary. And so therefore, taking the fact that for this to be true, q minus p squared must be less than 0, our relationship between q and p can be defined as q being less than p squared. For part C now, we're told that actually, an equilateral triangle forms between O, A, B, like this for instance, and that we need to express Q in terms of P, which basically means we need an equation for Q expressed in terms of P. Also, notice how I emphasized the point equilateral. Why did I do that? Pause the video and think about it. I did that because the fact that it's an equilateral triangle tells us that the angles here must be 60 degrees. That's useful, but it doesn't really help us yet. What other changes can we make to this triangle? Well, we can draw a perpendicular up to A, which has a length of P. And then we can recognise that this point here has a x value of root q minus p squared. So then, we basically have a right angled triangle, which means that p over q minus p squared is equal to root 3. Simplifying this down, we get to 3q is equal to 4p squared, which finally gives q is equal to 4 over 3 p squared.